Hey guys, Mr. Jenkins here with, this is not an official lesson like from the book, so there will be no homework to go with this, no additional practice assignment. This is just kind of an extension of 4-6, and just it ties a little bit of 4-1 into it. You'll have some test questions that are very, very similar to this, so it will be worth your while to watch this lesson either right now or kind of as you're working through the study guide. So remember, you're going to get the study guide on Monday, no school Tuesday, so question and answer on Wednesday, and then the test on Thursday. Okay, that's how it's going to go. So let's go ahead and get to it. And this is called Analyzing Graphs of Functions. Number 1, the graph below shows the distance that the Smiths drive on the first day of vacation. So we see our variables are time and distance. So distance depends on time there, or time is the input, distance is the output. First thing wants to know how much total time did they spend stopped? All right, so what does stopped mean? Stopped would mean that are we traveling any distance when we're stopped? No. Is time still going? Yes, time is always going. So this would be as time increases. So as we move to the right, this would be distance. Doesn't increase, doesn't decrease, it stays flat, right? So we're looking for kind of overall just a zero slope line. This would be a constant interval, right? So I'm gonna go ahead and highlight those spots. So from here to here and from here to here, okay? So we wanna go ahead and see what that total time is. Okay, and we'll just assume these in the middle are 0.5s. So I know the numbers are kind of hard to see, but we're counting by ones here. So we go from hour 2 to hour 3.5, so that'd be 1.5 hours. And then from hour 6 to hour 6.5, so that'd be 0.5 hours. So 1.5 plus a half is 2 total hours. Wants to know, part B wants to know, during which part of the graph are the Smiths moving fastest? And then can you think of a possible reason? And then when are they moving slowest? So fastest would be we are traveling a speed, right? So it's either going to be this interval, or this interval. So to look at fastest, you would want to cover the most distance in the least amount of time, right? The most distance in the least amount of time. So what would that look like as far as the slope of our line goes? That would be the one with the steepest slope, right? So it's kind of obviously not that one in the middle. So it's between these two. If you can't just look at it and tell, then you kind of have to do the math, right? So in this interval, I did 75 miles in 2 hours. So that would mean that, that's kind of my rate of speed, whatever 75 over 2 is. And then in this other interval, I went from 100 miles to 200 miles, so 100 miles in 2.5 hours. Okay, so you can compare them that way. Hopefully, you can just look at it and see that this is your fastest rate. Okay, so during which part of the graph are they moving the fastest? We can just say something like, let's just say they're moving fastest in the last interval. Or you could say from hour 6.5 to hour 9 if you wanted to be a little more specific. Can you think of a reason? I'm not going to write this down, but you might say, they're in a hurry to get where they're going. They're in a hurry to get to dinner. So it doesn't really matter on that reason. When are they moving the slowest? That's where our slope is the shallowest. So that would be in the middle of the day from our 3.5 to our 6. They move the slowest. And again, it says why. Make something up there. Maybe they're in traffic. C, if they started their trip at 5 a.m., how far did they travel before noon? Right? So if they started their trip at 5 a.m., that would mean that this is 5 a.m. 6, 7, 8, 9, 10, 11. Here would be noon, would be hour 7. All right, so overall, how far did they travel before noon? That's the question. So we went from 0 up to what? So we kind of have a point right there. You want to just kind of see where we are. So somewhere between 100 and 125. We'll just split the difference and call it 112.5. So all this is just really about reading a graph. Okay, I just looked at my filled out notes, and the first time I did this, I said it was about 120 miles. So so you can have some room for error there. All right, let's go to another one. This problem's really similar. It says Trey makes a rectangular dog pen using 10 yards of fencing. The graph shows the relationship between the length of the pen and the area of the pen. Okay. Part A, at what length or lengths would the area be 4 square yards? Okay. So it's hard to see here, but this is A. So this is our area. That'd be in square feet or square yards, I guess. All right. Square yards. And then this is the length. In yards. So at what length or lengths would the area be 4 square yards? So we just look, here's where area is 4 square yards. And so we have this point and this point. So it looks like when the length is 1 yard and when the length is 4. So we'll say when the length, or when L is 1 yard or 4 yards. Hopefully that pops up. Kind of having a little bit of trouble here. In the ordered pair, 2, 6, what does the y coordinate represent? Okay, so 2, 6. So it really doesn't matter that it's 2, 6. The y coordinate always represents the area. Okay, so we'll just be specific here. It says the area is 6 square yards when the length is 2 yards. So really it only asks me about the y coordinate, but notice I give a little more detail there to really show that I'm reading the graph. At which length or lengths will Trey maximize the total area in square yards? In other words, what's the highest point on the graph? So 2, 6 is close, 3, 6 is close, but we can do a little bit better. All right, so right here looks like kind of the tip top of the graph. We call that the vertex of a parabola. So it looks like it'd be probably 2.5. We maximize our area at, whatever it is, okay? So we'll say when L equals 2.5 yards. The area is max. Max. All right, so, and that's always going to be the case. You know, that's when it becomes a square. So that's when it'd be 2.5 by 2.5. And a square is always where you maximize your area if we're talking about rectangular stuff. All right, so I don't want this video to be terribly long, so I'm going to skip 3, but it will be on the filled out notes. I suggest you look over that. Number 4, well, I guess we'll go ahead and do this. We'll go ahead and try to sketch a graph of this. So looking at my variables here are time and speed. So we're looking at speed over time here. In interval A, the bus pulls away from a stop and increases speed. So as time is going, we are increasing in speed. So that would be a positive kind of slope. In interval B, the bus is at a constant rate of speed between stops. So constant would be flat. Interval, I probably could have made interval A a little shorter, maybe more like this, okay, but that's okay. Big thing is increasing constant. The bus is stopped. So really that should be the bus comes to a stop. So let's go ahead and draw what that might look like. So it's going to clearly have to slow down. It's not just stopped from here. So do a quick stop and then some time at 0 speed. So this together would be interval C, and then increases again. I will make that look like A. All right. So again, what matters here is pay attention to what your variables are. And in each interval, how would, you're thinking, how would speed change as time increases? Okay, if I'm increasing in speed, I would have an increasing interval. If I'm at a constant speed, I would have a constant interval, okay? All right, and then the last thing I really wanted to cover were these types of problems. These tend to give kids a lot of trouble when I've given this test in the past. So let me zoom in so we make sure that I see the numbers correctly. And you will have test questions pretty much just like this. All right, so it says for the following, define the domain and range of each relation, determine whether it is a function, okay? All right, so we're gonna do 2 ways to do the domain and range. We're gonna use inequalities, and we're gonna also use interval notation, okay? So these numbers are still hard to see. It looks like we are counting by 500s, okay? So I'm gonna go ahead and just so you can see it on your end, go ahead and give you the endpoints because that's all that really matters. So this is the point 0, 0. And notice that this is a line segment and not just a line that goes on forever because it ends in dots and not arrowheads. And then this would be the point. This is between 50 and 60, so we'll call it 55, comma, and then right on this line, so comma 2000. All right. And so then our domain, all right? So our domain is our side to side. How far does it span side to side, right? So it goes from here over to here, right? So we're looking at our x coordinates there. So it goes from 0 to 55, right? Now, how do we write that out? Notice these are also closed dots. So those numbers are included. So as an inequality, this is always going to be an and inequality, okay? Also, I think I skipped this part. They call this variable. Let me pull it up on my paper. I can hardly see it on my screen here. Sorry about this. Let's see. They call Okay, so they call what's on the x-axis t, and then the other one is a of t. Okay, so and that's just written. That's not anything I came up with on my own. So there's t, and then this one is called the a of t axis. Okay, so our input variable goes from 0 to 55. So we say 0 is less than or equal to t is less than or equal to 55. The range is talking about output variable. All right, so my output variable goes from here up to here, right? So that goes from 0 to 2000. All right, so that would be 0 is less than or equal to a of t is less than or equal to 2000. Okay, and then we'll recall interval notation. So we're not doing anything different here. We're just rewriting it in a different way. All right, so my domain would be, so 0 is my low point. 55 is my high point, and then just remember why I'm using brackets instead of parentheses. I'm using brackets because it's or equal to. And again, back to the graph, I know that because they were closed dots. All right, and then my range would be from 0 in bracket to 2000 bracket. Lastly, is it a function? So how can we tell by looking at a graph? Hopefully you're yelling at your screen, the vertical line test, Mr. Jenkins, and that would be correct, right? So is there a vertical line I can draw that is going to hit this relation in more than one spot? The answer is no. Okay, so it passes the vertical line test, so this would be a function. Yes. Okay, so when I was saying no, I kind of made that a little confusing. No, there is no vertical line that would touch in more than one spot, so yes, it is a function. It passes the vertical line test. All right, let's do one more. I'm going to go a little bit quicker. This one right here does not end in dots, right? So we have to assume that it continues on forever. Okay, this is called a parabola, which you don't know much about a parabola, but so, you know, it kind of is hard to tell, is there a side-to-side limit? Well, if that arrow is pointing to the, you know, to the northwest and that one's pointing to the northeast, right? It can go west forever and east forever. So there is, you know, there is no restriction there. So our domain would be all real numbers. So you could just say all real numbers. If we wanted to write an inequality like that, we would just say from negative infinity to infinity. So to put it in inequality form, that would just be negative infinity is less than x is less than positive infinity. So remember that the symbol for infinity is just like a sideways 8. Notice I didn't do equal to there because infinity is not a real number. All right, so then the range, there is a limitation on the range because there is a turning point in the graph, right? So kind of on this side, it's like as x is increasing, y is decreasing. So it's a decreasing function here, but then it becomes an increasing function. So that means that I do have a low point, which it looks like is the vertex, or is the origin. All right, so that would be the point 0, 0. All right, that means that my lower limit is 0, and then again back to these arrows. Both of these are pointing north, so that means that it could go up forever. So there is no upper limit, right? So then my range would be, we would say from 0 less than or equal to y, and is less than infinity. We haven't talked a whole lot about infinity either, but if there is no limit, that's your limit, infinity. Okay, so in interval notation, my domain would be parentheses, negative infinity, comma, positive infinity, close parentheses. My range would be bracket 0, comma, infinity, close parentheses. So this one's nice because I have the bracket and the parentheses. So it kind of highlights the difference there. All right, and lastly, is it a function? I don't see any vertical line I could draw that would touch in more than one place. So this would be a yes. It also passes the vertical line test, so it's a function. All right, so like I said, no extra homework that goes with this video. This will just supplement your study guide. There are some test questions that are almost exactly like this problem, so it will be a helpful video. It will be worth your time. And as always, hopefully this stuff helps. That's why I'm doing them. Let me know if you guys have any questions about these examples or anything else, your Math Excel work, your study guide, etc. Thanks and have a nice day.